Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6. Well, this is question number 6 from this GCE. This is Edexcel paper 1. This is the AS level paper 1, pure mathematics. This is from the mock set 1 papers. And this question is also a question that I have included in my end of topic worksheet for my Cambridge equation of circles end of topic worksheet. This is question 7 from that worksheet. I've included questions from other examining boards in this particular worksheet because this is a new topic in Cambridge, which after 2000 or prior to 2020, you won't find any questions on it. So I've chosen from other examining boards to leave those newer questions like closer to the exam for my students to practice from unseen. So now we've got here a question about the points P, Q, and R, which the coordinates are given. All right, so that's P, Q, and R coordinates. We've got to show the angle PQR is 90 degrees. Now, this is a pretty straightforward question. We don't really need to make a diagram, but I'm going to do it just so that those students who can't picture what's happening will be able to picture it. You don't really need to use a diagram once you understand in the exam, but diagrams are always good in these type of topics. So you have P, -5, -5. So -5, -5, somewhere like over here. That's the point P. This is Y and this is X. Then we have Q, which is 7, 1. So somewhere like over here. Say that's 7 and say that's 1. Something like that. And then 9 and -3, which will be somewhere down here. 9 and -3. Let's make this a bit bigger to make it a bit more realistic. Okay, so we have 9 and -3. -3, something like over here. Right? And we have to show, so this is P, and this is Q, and this is R. And we have to show basically that the line PQ and QR meet at right angles. We have to show that we have to prove that this is a right angle. Okay, that's what we have to show. This is a right angle. Okay, so it's 90 degrees. So we know that basically, we know that if you have two lines which are perpendicular, then the gradients are negative reciprocals, or the product of their two gradients is equal to 1. So if we have the gradient of PQ and we multiply it by the gradient of QR, and that gives us -1, therefore PQ is perpendicular to QR, right? So we need to find the gradient of PQ, which is equal to, now we got the coordinates of PQ and R. So we have P, which is -5, -5. We have Q, which is 7 and 1. And we have R, which is 9 and -3. So for PQ, we can say the change in Y, which is 1 minus -5, over the change in X, which is 7 minus -5. Well, that gives us 1 plus 5, which is 6, over 7 plus 5, which is 12. That's a half. And then we can find the gradient of the other line, which is QR. Okay, so the gradient of QR, we can see here, is going to be the change in Y. So the gradient of QR is the change in Y, which is -3 minus 1, over the change in X, which is 9 minus 7. And that gives you -4 over 2, which is equal to -2. So if we do the gradient of PQ times the gradient of QR, we can see we're going to get a half multiplied by -2, which is -1. So we know that basically that means they're negative reciprocals, as we can see. So we can say as the gradient of PQ times the gradient of QR is equal to -1, then PQ and QR are perpendicular. We're just giving the reasoning here. So the angle PQR must be equal to 90 degrees. perpendicular lines meet at 90 degrees. So that's a complete kind of proof that this angle here is 90 degrees using the fact that the gradients of the two lines meet at, or the product is -1. Whenever the product of two lines, the gradients of the lines is -1, they will be perpendicular. If the gradients are the same, they will be parallel. Right, so there's the answer to part A. Now then it says for part B, it says given that P, Q, and R each lie on a circle, find an equation for that circle. So these 3 points all lie on a circle. So we've got to find the equation for a circle. So we got to understand that in a circle, so I'm going to draw a circle now. Okay, so I'm going to mark a center. Okay, so this is something we have to remember from our circle theorems from IGCSE. So I'm going to draw a circle, and what we should understand is that in a circle, the diameter always subtends an angle of 90 degrees. Okay, so if we look at this, PR would be the diameter of the circle. Why? Because it subtends an angle of 90 degrees. So if I draw PR like this, so that's P and that's R, and that's the center. Okay, so here you have the center of the circle. Okay, let's call that O. We have P, we have R. And Q would be up here. Okay, Q would be up here somewhere, such that this angle here is going to be 90 degrees. Angle subtended by this diameter will be 90 degrees. Okay, so this right angle here, so this is Q. Right, so basically that's how this circle would look. If you were to draw the circle, it would look something like this, because we know that it's the diameter of the circle will subtend an angle of 90 degrees. Okay, so if there's an angle of 90 degrees and PQ are all parts or all points of the circle, that means that this is where the right angle is. So now we can say that PR is the diameter of this circle. So this circle C has PR as its diameter. Okay, so we can see C has PR as its diameter. Okay, so we need to work out the equation of the circle is given by x minus a squared plus y minus b squared equals r squared. So we need to find the center of the circle. The center of the circle is AB. Center is AB. That's what this center is. Now we know the coordinates of P, as we were told, is -5, -5, and R is 9, -3. So that's -5, -5, and R, its coordinates were 9 and -3. Okay, so we know that. So the midpoint of PR is going to be the center of the circle. So we're going to say O is going to be -5 plus 9. It's like the midpoint. You add them together, divide by 2. And you got -5 plus -3 divided by 2. So that's going to be, you say the center of the circle is that's -5 plus 9, which is 4. 4 over 2 is 2. And you got -5 minus 3, which is -8. -8 over 2 is -4. So the center of the circle is 2 and -4. So I know my A and my B here. Now I've got to find the radius of the circle. So to find the radius of the circle, I can find the magnitude of PR. Okay, that will be the diameter of the circle. So the diameter is going to be the magnitude of PR. So we can use the formula for the length between P and R. So I know that's equal to the square root of, we're going to have -5 minus 9 squared, that's a change in x, plus -5 minus -3, which is +3 squared. So the diameter is going to be the square root of, that's minus 14 squared, plus -5 plus 3 is -2 all squared. Okay, so that gives us what? We have 14 squared plus 2 squared. Also minus will become positive anyway. That's equal to 200. That's equal to the square root of 200. Okay, so the square root of 200 is the diameter, and we can simplify this. We can say that this is like 100 times 2, so it's going to be 10 times root 2. It's going to be square root of 100 times square root of 2, which is 10 root 2, and therefore the radius is equal to a half of the diameter, which is a half times 10 root 2, which is 5 times root 2. So therefore we can say the radius squared, which is what we need here, is going to be 25 times 2, because if you square 5, you get 25. If you square root 2, you get 2, which is 50. So therefore we can say that the equation of C, okay, so we can say C, the circle, has equation x. So we know that the center of the circle is 2, -4, and the radius is equal to 50, or the radius squared is equal to 50. All right, so we can say x minus a, so x minus 2 squared plus y minus -4, so y plus 4 squared equals 50, r squared, which is 50. All right, so therefore we have the equation of our circle. Right, so the important thing in this question is to understand that the diameter will always subtend an angle of 90 degrees. So it's something that we need to remember from basically some of the laws that we learned of circles in IGCSE. They do come back to haunt us in AS and A-level sometimes. So there we have the answer to question number 6 from this mock set paper, and number 7 from our end of topic worksheet. I hope that was clear. Other questions from this particular paper, if I ever do answer them, will be found in the playlist that I'll put over here. Other questions from the topic of circles, equations of circles from my collection of Cambridge, you can find in the playlist over here. My Edexcel collection, you will find in the playlist in this area over here, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.